Hello, today we're going to look at a different part of projectile motion. So far, we've looked at only when the ball or object will hit the ground, but that's not the only question that you might be asked. So, for example, here's a little sketch of me throwing the balls off of the chair like I did a couple days ago. And, we had talked about when the ball hit the ground. I'm going to come down here to this non-example section. We had been thinking about when it goes up and then comes down and how long it would take to hit the ground down here. But another common question that's asked is when the ball would reach its maximum height. So in our diagram here, where it says illustration, we're looking at this spot right here, where the ball reaches its maximum height. And so this is at the top of the parabola, where it reaches its maximum height. And if you don't remember, because it's been way back in Unit 1, all the way back in the fall, the term that we use for that point on the parabola is called the vertex. And so again, this whole section is going to be about what we call the maximum of a graph, which is the highest point on that graph. And so, again, if we're thinking about, a rocket launching, you could draw a little picture here if you want, or what. But, if we think about some other sort of object, like a ball going up in the air, coming down, we are looking for this spot at the top. What is the highest that it can go? And so the question really is, because we talked about this very, very, very briefly in the fall. So our goal kind of today is, how do we find that vertex of a parabola? Because my guess is that you've probably forgotten. So there's a formula that we use, and interestingly enough, it's actually based on the quadratic formula we've been working with. And that formula is x equals negative b over 2a. If you recall our quadratic formula, that's actually the very beginning of the top of the quadratic formula and the bottom of the quadratic formula. All that's missing is the plus or minus square root section. And so, I said x equals, but, in this case, we often use t. So if you want to think about it as x or t equals negative b over t 2a, and that's going to give us the time that it takes for the ball to reach the top of the parabola. Now, once you know the time it takes, so you're going to have a time, and then you're going to have a height. Once you know the time that it takes, you can plug that time into your equation or your function to find the height. So, for example, we're going to come down here to our sample problems. If an object is launched directly upward at 64 feet per second, so we're dealing with feet. So I'm going to have my gravity of negative 16 feet per second squared. It tells me that I'm going to go upward at 64 feet per second for my launch speed or velocity. And from a platform 80 feet high. So that's my starting height. So that's what my equation is going to look like. And we want to find the function of the height of this object at any given time t. That's our equation. So if we want to know the maximum height, what that's really asking is, where is the vertex, right? Where is the vertex? What is the top spot on that parabola, right? And again, to find the x value of this point, or t for time, we would take our negative b over 2a. Again, it's the very beginning of each, the top and bottom of the quadratic formula. And so if we do that, we would have a negative sign. Then my b value is 64 over 2 times my a value is negative 16. Well, what that means is my top would be negative 64 my bottom would be negative 32. Negative 64 divided by negative 32 means that it takes 2 seconds for that ball, or in this case it says object, doesn't say a ball, but it would take 2 seconds for that object to reach this highest point up here. But again, that's only the first part of that vertex point. There is a y value as well of that vertex point. In this case, it would be a height, h of t. However, we have our full equation. So now that we know our time, t is 2 seconds, all we have to do is plug that 2 seconds into that equation. So if we take negative 16 times 2 squared plus 64 times 2 plus 80. Again, you're welcome to type this into your calculator. I will challenge you that if you do that, please make sure to type in the parentheses because, again, it is very common for there to be challenges with exponents when you do not use parentheses. So make sure to, every time you have exponents, to make sure you're using parentheses. But if we did this by hand, my 2 squared here would be 4. And that 4 times that negative 16 would be negative 64. My 64 times 2 would be 128. And then plus 80. Then if I go ahead and combine negative 64 and 128, that would give me 64 again. Plus 80, and that would give me 144, and in this case for height, our unit is feet. So that tells me that it takes 2 seconds for that object to reach a height of 144 feet. So this is 144, and then it begins falling back down to the ground. For number 2, we have a pistol that's accidentally discharged vertically upward from a height of 3 feet. So if we think about our equation here, we're looking at feet again. So it's going to be negative 16 t squared for feet. It's going to go upward. This is a pistol, so we're talking about it's going to have a very, very fast initial velocity, so that beginning speed it is shot at would be 200 t. But again, at a height of 3 feet above the ground. So again, if we want to know that maximum height, we're going to need to know both the x and the y value, or in this case, the t and the h value of that vertex point. And so we start with that x equals negative b over 2a. In this case, that would be negative 200 divided by 2 times negative 16. I mean, the nice thing about the projectile motion problems is you can pretty reliably predict what that bottom is going to be, because A is always going to be negative 16 if we are talking about feet. So it's negative 200 over negative 32. And sometimes with these problems, we do get decimals. So, it's okay if you need to break out a calculator for some of these calculations. If we take negative 200 divided by negative 32, we get 6.25. So it's going to take 6.25 seconds for it to reach its maximum height. The reason this takes so long in this case is, we're talking about a pistol, so that very high initial velocity means it has a lot of energy to take a while to get to that maximum height. Again, we're going to take that 6.25 seconds and plug it in to that equation that we wrote. And so we're taking negative 16 times 6.25 squared plus 200 times 6.25 plus 3. And you could very well, type that whole thing into your calculator in one go, but I'm going to do it a piece at a time here. 6.25 squared is a little over 39 if you did that in your calculator. And when you multiply that then times negative 16, you actually get a negative 625. And then when you take that 200 times 6.25, you get 1,250. And then your 3. And when you put all of those together, negative 625, 1,250, and 3, you end up with a maximum height of 628 feet. Again, that is quite high, but again, that makes sense because it had a lot of initial velocity to overcome that gravity. Number 3 here, some fireworks are fired vertically into the air from the ground at an initial velocity of 80 feet per second. Once again, we're in feet, so our formula, our equation, we'll start with that gravity of negative 16 feet per second. Again, the launch is 80 feet per second. And then again, notice from the ground, so that height here is 0. Again, if I want to do the highest point it reaches, I'm looking again for that vertex point, starting with that negative b over 2a, the beginning of the top and bottom of the quadratic formula that we were using for the other formula. Let's see here. So negative b over 2a would be negative 80 over, once again, 2 times negative 16, because our gravity has not changed. All these problems have been here on Earth. So that makes us negative 80 over negative 32, which when we divide those, we get 2.5 seconds. .5 seconds we would then take and plug into our equation to figure out how high it actually goes in that time, because that's our time. It goes in 4t. And you're welcome to type that all in your calculator at once, but I'm going to do it a piece at a time. If we start with that 2.5 squared, that's going to give you 6.25, and then we're going to multiply that by that negative 16. And so this part will give you negative 100. 80 times 2.5 will give you 200. And then we have our plus 0. And so negative 100 plus 200 plus 0 is 100 feet. And one more example for us here. A tennis ball is propelled upward from the face of a racket at 40 feet per second. The racket face is 3 feet above the ground when it makes contact. At what time will the ball be at its highest point? So again, one more time with our equation, we're still talking feet. So we still have our negative 16 feet per second gravity. Our launch speed is 40 feet per second and it's 3 feet above the ground. We're looking for that highest point. So we're looking again for that vertex of the parabola, which is going to have an x value and a y value. In this case, a time and a height. To find the x value, we use that part of the quadratic formula, negative b over 2a. In this case, that's negative 40 over 2 times negative 16. Can you Notice that negative 32 being a recurring theme because the gravity on Earth doesn't change. If it does, it's going to have catastrophic consequences. But that is 1.25. So again, 1.25 seconds for us to hit that highest point. So that's the x value of our vertex, or again, in this case, the t value, the time. We're going to plug that in again, that function, that equation, to see how high it goes in that time that it's going upward. So we plug that in one more time. You could type all of that straight into your calculator, including the parentheses, or you could just go ahead and start by taking that 1.25 squared times that negative 16, which gives you a negative 25. Then you could take the 40 times the 1.25, that would give you 50, plus the 3. And when you add all those together, you're going to get 28 feet high.